Okay, so we're recording. We're going over mock exam number 2 on the Albert IO website. It's Friday, June 4th, and we're preparing for the June 9th AP exam. So we're going to talk about multiple choice without a calculator. Here's number 1. And shoot, I don't want the answers to be shown. Hold on a sec. Oh, what the heck? That's fine. It's shown. So here they're asking you to evaluate the following limit. If you were to plug in 0, you would get 0 over 0. So this could lend itself well to doing L'Hopital's rule. Because again, if you were to plug in 0, you have natural log of 2 over 2 over 0, or natural log of 1 over 0, or 0 over 0, which of course is indeterminate. So if you do L'Hopital's rule, you'd have 1 over, remember L'Hopital's rule is when you do the derivative both top and bottom. So if you have 1 over that expression, and the derivative of the bottoms will just be 1. You flip over that fraction here, and actually we should be doing chain rule. I kind of forgot to do that. So if you think about it, that's 2 over 2 plus half h. When I do that derivative, I get 0 plus 1/2. So I got to do a chain rule as well, which I forgot to do. And of course, you divide by 1. Now you can plug in 0 for h, and you will get 1/2. So that's what the answers be. So that's how that one would work itself out. Go to the next one. Here we have an integral. So the way you're going to want to approach this one here, it's a little bit complex, but it's 1 over root. And you could actually think of this, if you pull a negative out, you'd have that. Or we could even think of it like this. Push that negative 8 off to the side and factor the negative between the first two terms. Then you take half of 6 squared, which is 9. But really you're going to put a plus 9 here, because what you really incorporated is a negative 9. Right? If you assume the minus, we really introduced a negative 9. So you want to make sure everything balances out and gets it back to the original statement. So this actually becomes negative x plus 3 squared, and of course it's a plus 1. Now inverse sine, the derivative inverse sine, if you do d dx of that, is 1 over root 1 minus x squared. And in case you forgot your rules, if you go to Schoology, there's a cheat sheet called derivative cheat sheet and rules, I think. Here, there we go. And you can access this in Schoology. If you skip to the second page, yeah, there we go. Derivative of inverse sine is 1 over root 1 minus x squared. So I could rewrite this integral as 1 over root 1 minus x plus 3 squared. Okay. So replace the x here with x plus 3. So it's the inverse sine over that is just x plus 3. And then, of course, a plus c. So a little tricky. But if you do see the inverse sign, that kind of is a little trigger. And you would have to kind of go through completing the square to do that. Actually, I was thinking about talking about that anyway. There's actually a worksheet in the AP review folder. In fact, actually, it's right here. Worksheets. And it's called, I believe, yeah. Worksheet on additional algebraic techniques for anti-differentiating. That's exactly what we did here. So right out of the gate, they give us 2 pretty advanced problems. But it's good because, these are topics we didn't quite cover during our session. Let's keep moving. And please feel free to ask questions if you're stuck. Now we'll get back to one that's a little more fall semester stuff. Which of the following statements are true? So if we look at 0, a course limit won't exist because in order for a limit to exist, you need the left-hand limit to equal the right-hand limit. And you clearly see that we're going down this way to negative infinity, going up that way towards positive infinity. So course limit won't exist because the left hand doesn't equal the right hand limit. Now, as x approaches 2, we have this. As x approaches 1, it's of course higher. So yeah, the limit as x approaches 2 is less than as x approaches 1. So I would agree with that. If x approaching infinity and negative infinity, they're both going towards 0. Remember, that's all about approach. I say that's true. Now, if we're approaching 0 from the left, that's going towards negative infinity. That's going towards positive infinity. That's why we have the vertical asymptote. That's what infinite discontinuities come about. When x is approaching some number from both the left and right, if it's an infinite nature to your output limit, that's going to be a vertical asymptote. So that's why it's just 1, 2, and 3. Get back to valuing integrals again. Now, the one thing about the AP exam is that because you're doing it digital, you won't be able to skip around. So once you kind of submit an answer, you have to kind of stick with it. So you might want to be mindful about that because these 2 questions I think were much easier than the previous 2. It's a U sub. That U equal negative 2x, right? So du dx is negative 2. If you move things around, dx is du over negative 2. And if you plug 0 in for x, u is 1. Plug in 1 for x is negative 2. So that's EU plus C. Answer review is just EU. But don't worry about the plus C because it's definite integral. And you plug that in. So you can have negative 1/2 e to negative 2 minus negative 1/2 e to the 0. And that comes to positive. E to the 0 is just 1, so it's just going to be d. That's what we get d as the answer. Okay. So hopefully we're okay with that one. Well, I would get a pretty wacky one, but I think we can handle this one. Let's see here. So let Riemann sum. Apparently, it equals that formula. So find the value oh, okay. When you have a Riemann sum, you take the limit as n approaches infinity of your actual Riemann sum. That'll be the value of the integral. So if you think about it, that's going to be 6n cubed up top with a bunch of junk that follows, and you have n cubed. And so because the degrees are the same, we know how to take that limit. So that's why it's just going to be 6. So you have to be able to recognize this is going back to 6.2, our lecture notes. So spring semester lecture notes, fill out notes, 6.2. Yeah. So the Riemann sum is going to be some expression in terms of n. How many n subliminals you have, and you're doing the limits n approaches infinity. That's going to be the value of the integral. So that's really assessing that question. And then you guys should know how to find the limits n approaches infinity for a rational function. We did do that in the first semester. So it's kind of combining all those different topics. Let's look at 6. This is involving product rule. So what you'll need to do is let this be like the first function. Call it f. Let that be g. Actually, or we can call like h, g, and h, because the whole thing is f, to avoid confusion. So remember, it's going to be g prime times h plus g times h prime. Go ahead and do that. Plug in 2, and see if you get this answer here. I'll be right back. Okay, so hopefully you got the answer. Where the derivative of e to the 4x is e to the 4x. This is a chain rule. Multiply by 4, and you leave h alone. Then plus the g e to the 4x, and then times that, which is 2x. Plug in 2, you have 4e8 times 7 plus e to the 8 times 4. So it's 28e8 plus 4e8 was 32e8. So that's that one. Let's take a look at solve a differential equation. So for this one here, we're going to isolate y prime. You can probably factor on x and a 2x. Why not? And y prime, remember, is dy over dx, so I probably should have just done that. So dy over 5 minus y equals 2x dx. You integrate it, you get 2x squared over 2 plus c, and that's natural log of 5 minus y. However, you got to put a negative to the left as well. And those cancel. Then you have initial condition, you got to plug 4 and 1. Usually they say this for, just so you know, pre-response question, not multiple choice. So you plug in 4 here and 1 here. So it's negative natural log of 1 equals 1 plus c. Natural log 1 is 0, so c is going to be negative 1. We're not out of the woods yet. Negative natural log 5 minus y equals x squared minus 1. Multiply both sides by negative 1. E to the x squared minus 1. Sorry, I'm jumping the gun here. 1 minus x squared. Then I got to raise e to both sides. So 5 minus y is going to be plus or minus that. Now, you want to plug your initial condition. So 4 for y and 1 for x. That's e to the 0, and you want 1 on the left side, so you want 1 on the right side, so it's going to say positive. So, yeah, this is a really cruel problem to put multiple choice. So 5 minus y equals e1 minus x squared. We'll put y over here, e1 minus x squared over here, and that's what the answer is at. So that's a review of differential equations, which is, I think, 7.4. And Julie, I know I sent you some videos on that, so now you've seen that in action. These are always good problems where you give an f prime graph, and you want to get the graph of f. So you want to find the x-intercepts. F prime equals 0 at x equals 1 and 3. Okay, 1 and 3. F prime is positive here and negative here. So that's going to be a relative max. That's how you have to interpret it. And here is just going to be a stationary point. You have a horizontal tangent, but no extrema, no extreme. And of course, there's positive before and after. So basically be rising. So we know we need to have a max at 3, a relative max, which it looks like we kind of get that for both B and C. But you don't want a discontinuity at 2 because the derivative does exist at x equals 2. So it's a corner, which means the second derivative won't exist at x equals 2. So C looks really good to me. Because your tangent lines are all positive here. I mean, 0 here, positive, hits a peak. That's negative after that. And by the way, it looks like it's concave down from like 2 to 5. You can see the derivative is losing value during that time frame. So and it's kind of a constant anyway from 4 to whatever, so it looks like it's a straight line there. And it's a negative derivative, and you have a negative slope from 4 to 5. So this here you want to recognize the formal definition of the derivative, which is the limit definition. So remember, that's the limit definition. F of x is right here. Or if you're putting something in, the number you're plugging in is going to be inside the parentheses for f of x. So in this case, our function is going to be inverse tan of x. And this represents f prime of pi over 4. Okay. So derivative inverse tan is 1 over 1 plus x squared. You got to know your formulas there. Now, because you are doing it at home, I don't think there's going to be a camera on you. You might as well have the cheat sheet in front of you. So I would actually strongly recommend you print it from Schoology. If you can't access, I think we're keeping Schoology open for another week or so. If you can't find or access it or whatever, let me know, I'll email it to you. But you totally want to have that because then you can say, oh yeah, that's what I do. Right? Put in pi over 4. You have that you multiply top and bottom by 16. That's how you get B. Okay, then we'll do 10. Then we'll have you guys try a couple problems. Okay. So that's a third derivative. Okay. So I just want you to do a derivative a couple times. Derivative sign is cosine, so it's negative cosine x. And that's negative 4 times negative sine 2x and times 2. And a double negative, so it's negative cos x plus 8 sine 2x. Now you got to do it again. Derivative sine, cosine is negative sine. So it becomes negative sine x plus 8 times cosine 2x, but then times another 2 as part of the chain rule. And that's why we get B as our answer. So hopefully that one seems pretty straightforward. Okay. Let me have you guys try some multiple choice problems right now. So you can go to Schoology and access this under the multiple choice calculator, non-calc. The file is actually called multiple choice no calculator. And let's take a look at 2008. Let's see here. I think 12, 13. Yeah, let's going to give 12 through 16 a shot. So we'll give you guys a few minutes. So let's go try number 12, number 13 first. We'll say 4 minutes, and I'll actually pause the recording. Okay. So here we're looking at now section 1B, with multiple choice with a calculator. And this is a very calculator-specific problem. This is going to be velocity or linear motion. They give you the velocity function. They want the total distance traveled from 1 to 4, and they also give you the initial position. Now in this case, it's going to be FTC, because if you do the integral, well, first of all, V of t is S prime of t. That we should know. You integrate from 1 to 4 of S prime of t dt. Now that's going to equal S4 minus S1. That's FTC. So really, you're integrating this bad boy here from 1 to 4 of our V of t function, or S prime t, same thing, but the function itself is t minus 1 cubed minus 2t dt. And then, of course, S4 is what we're trying to find, because you're, oh, wait 1 sec, they want the total distance. Yikes. Okay, sorry. I thought they wanted position at 4. Well, in this case, I do need to do an absolute value then. And actually, the initial condition actually doesn't really matter. Yeah, you just want to told us to travel. So yeah, you're just doing that. I'm not sure why they even gave that to us. I mean, it's good we had that discussion about FTC, but yeah, really you're just doing that then. That's where you totally gonna use your calculator. So we'll punch it in. You may want to do the same as well, so you get the practice. So alpha window, or if you call it the integral, you alpha window. From 1 to 4. Alpha is also very cool to pull up abs or math. And also you can do math, excuse me, and go down and get F in it there as well. X minus 1 cubed minus 2x dx. And I do get 13.688. So yeah, that was weird that they gave you the initial condition. Rarely does the College Board do something that threw you off, but that's all. Okay, let's see if we find another calculus-specific question. Okay, that one for sure. So do you want to find the points of inflection? So to give you the derivative, so you're going to need to find the second derivative. And you want the second derivative equals 0, or actually change sign for point of inflection. So here's what you're going to do. You're going to graph this. You're going to go to y equals. And even though you're working at home and you might be tempted to use Desmos, I don't know if the College Board, the browser you're going to be on, or whatever software you're using for digital exam. is going to require you to, or if it's going to, disable your ability to view other sites. So you don't want to use a calculator anyway. So if I go to y equals, and then under y1, f net function is 5 raised, gosh, it's hard to read, x cubed minus 0.23 x squared. Oh, okay, let's try that again. I messed it up. X squared minus 0.23 x squared. Okay, that's 5 raised to the x cubed. Try it again. All right, minus 6x plus 1. Yeah. Okay, and then you want to do the derivative of that. So that's under y1. Now y2 is going to be the derivative of y1. So you can call it derivative by hitting alpha window, and hit alpha trace to call it y1. So under y2, you hit alpha window and deriv, which is option 3. Obviously doing ddx, and hit alpha trace and put y1 inside that parentheses there. And then you can put x equals x. Okay, now we're looking at the values and the choices. We may need to make sure our window maybe go from like negative 30 to 30, to 30, or negative 30 to 5 or something. And you can turn off the first. You could also turn off y1. To turn off y1, just go to the equal sign, hit enter. We go to window. We'll go from negative 30 to 10. And let's hit graph. It'll be really slow. It should be slow because it's trying to do the derivative of the function. So it looks like I probably get something at around negative 13. It looks like it's crossing at 1. So you're looking for the x-intercepts. So this is a second derivative graph, by the way. So the second derivative was positive, then became negative. Those negative became positive after that. That's why it's C. Yeah, 0.7816. Oh, look, that seems to make sense. So that's how you use the calculator for that one. Here's yet another calculator problem. I'll do one more, and then I'll have you guys try a couple. So here they give you the rate at which snow is falling. So it's actually a derivative. From 0 to 7 is a range, and they want from 1 to 4, and T represents the number of hours after midnight, because that's what they said so. Okay. How many inches accumulated during that time? Well, let's think of what were the units? Did it give us units at all? Inches per hour, fine. So let's say A of T is the amount of snow. Okay, so that's the amount of snow. So A prime of T is S of T. Okay, A prime of T is S of T. So when you're integrating A prime of T for 1 to 4 of dt, that's A4 minus A1. Okay, because you're doing the integral of a derivative. And that's what we want. We want to know how much snow is accumulated from 1 to 4 a.m. So this is going to be my answer. I don't know what that is, but I could actually just take my function, put it right there, dt, and that's all you do. You have to be able to kind of interpret that correctly. So you do this in the home screen, f and int. You could probably do that by hand, but why? 0.005 x squared. I'm sure the font will be bigger on the real thing. 0.15x plus 0.82. Yeah, see what happens. You get 1.44. There we go. Okay. Let's see if we can find another calculator specific problem. Okay. Um, one sec. Let's move a little further ahead. Okay, here we go. This is doing the volume, and I think that's a good thing to review as well. So you have two curves. By the way, x equals 0, y equals 0. X equals 0 is the y-axis, y equals 0 is the x-axis. It means you're just bounded in the first quadrant. The cross sections are perpendicular to the x-axis or equal out triangle with the volume of the solid. Okay, so this is section 8.3. You may want to graph the function in your calculator so you know how it looks. I mean, negative 2x plus 10, I know is a line. That's easy. I know that. And those are the intercepts of it, by the way. Then here, I think it looks kind of like this. I'm not 100% sure. I probably should graph it in my calculator. Well, we've got this in the calculator anyway. So let's call this y1. Let's call this y2. That's usually a good idea. X cubed minus x squared plus 8. And of course, negative 2x plus 10. All right, come on. Graph the center window. Yeah, so that was a little off my graph. That's okay. So I'm looking at this region right here. Okay. And I have equal out triangles where the bases are perpendicular to the x-axis. So it kind of looks like that are coming out of the page. Now, this right here is going to be my base, right? That right there is going to be my height. And because equal out triangle, you can kind of look at like this here. That is 60 degrees straight up. So the height will depend on my base. And my base is right here, by the way. And that's going to be, we'll call this S over 2. So I call the whole side just S. Now S is the difference in those y coordinates. So you could actually find this endpoint here of that base, which is going to be x comma negative 2x plus 10, because the y value on the line is determined by negative 2x plus 10 expression, right? That's the expression that determines that y value. And then here, that's going to be x comma x cubed minus x squared plus 8. Okay. So side length is going to be different to those. Negative 2x plus 10 minus x cubed minus x squared plus 8. Now the height is going to be, if you know your ratios well, it's going to be root 3, because this is s right here. So the height here is actually going to be s root 3 over 2. Okay, so I could throw that expression in for s. So the area of a equal triangle is 1/2 times base times height, or 1/2 times s root 3 over 2. or s squared root 3 over 4. Now, when you integrate this, you're integrating from 0 or from a to b. It's definitely starting at x equals 0, and then we have to find where they intersect. So I'll call that x for now, or we'll call it a or b, whatever you want to call it. And then it's just the area in terms of x times dx. That's really what you need to do. So let's do some green over here. So to find that point of intersection, that's why I need to punch these in. Oh, why did I just delete that? That was not smart. X cubed minus x squared plus 8. Okay, zoom, option 6. So we'll see where they intersect. 1, 2, 3. So intersects at, oh, okay, 1. That's nice. So it's going from 0 to 1. And your area in terms of x, so this is x right here, and actually we may want to, well, or you could just say this. It's going to be s squared root 3 over 4. So I'll put root 3 over 4 off to the left here. And s squared, our s is simply just going to be y2 minus y1. So you're going to do y2 minus y1 squared dx. You have to know some of your plane geometry as well. So I do this in the home screen. Fn ends from 0 to 1. y2 minus y1 squared, so alpha trace y2 minus alpha trace y1 squared dx multiplied by root 3 divided by 4. So you should get point 639. I don't get that as an answer. What do I did wrong? You have 64.09. Okay, I didn't read that carefully enough. My region was incorrect. Yikes. It's bounded by both x equals 0 and y equals 0. I did say that, but it's actually, this is the region. Ugh, I don't want to delete this whole thing. Yeah, okay. Yikes. So your triangles are going to be more like that. So it's a much bigger region. So we're going from 0 to 5. And darn, we actually have to partition this as well. Okay, so I'll do this quickly. It's a little frustrating. Here we go. At least I know the partitions at 1. So you're going to have an equilateral triangle that looks like this, and another region that does this. Okay. So I'll do 2 separate intervals from 0 to 1 of y2. And that's going to be just y2 squared. I still have the root 3 over 4 on the outside. Plus the other integral from 1 to 5. You still have the root 3 over 4 on the outside. And the s is going to be turned from here to here, or just, actually that's y2 squared. That's y1 squared. Okay. Thank you. Alpha trace. Fn 0, 1. Alpha trace y1 squared dx. Okay. And then we get to the other. Now we're in business. 1 to 5. Alpha trace y2 squared dx. And times root 3. And divided by 4. Yeah, you do get 64.09. So my apologies, I had the wrong region. The way I had done it was if you're just bounded by the y-axis or x equals 0. I was kind of ignoring this part. That was my fault. Okay, so I'm gonna have you guys try some now. So go back to but we'll do multiple choice, calculate aloud. Look at 2008 again. We'll start with 78. I'll give you guys a couple minutes and I'll stop the recording.